Huh? One second. Cool. So this didn't quite work, but it's definitely worth sweeping. And see if they've linked me anything else. I think Lucas sent me a PR. Keep this. I can see myself live. Hey, how's it going, man? This did not work. This is no bueno. Lucas sent me a PR, I think, so I should check that first. I don't know if he sent me a PR or he just like... You can boost LR as big as 1.8 and reduce it as little as 0.001. You can also have scheduler for LR. What is LR preconditioning? Do you anneal both or no? Right now I have cosine annealing on just the learning rate. But it's not going to do anything because this is literally like 1% into training. So like scheduling this over training isn't going to do anything because this is like 1% of training. You see? Like you got to zoom out on this thing. So this is the actual graph, right? Is big. This axis is in tens of billions, so this is 40 billion steps. And if you want to see like how far off this env is from solved, this goes to 3.5. The max is, I believe, 20 or 25. Where's this thing Evan sent me? You sent me a... His GitHub is Evan at your service. That's funny as hell. One is the learning rate of the neural net, and the one is the learning rate of the subproblem to learn the preconditioner. Okay, so I can sweep those. BRB, yeah. I can sweep those. The sweeps take a good while, you know? Move the Discord. I can see it over here on the side. Heavy ball cron. Where is his optimizer that he added? Oh, hey, Evan. Evan's here. Yeah, this is the same Evan. I don't know if he's watching stream or not. Where's this thing? So this is just like loss go here. Closure. Oh, this is gross. I freaking hate closures, but whatever. If it works, it works. Freaking Jackson, my PyTorch. I thought it was it 4 each Newton PSGD, this thing? Did it blind without testing? And give a list of hypers. To give it a closure. Not enough values to unpack. Not enough values to unpack. Expected 2 got 0. Loss equals heavy ball utils. Handle closure. Doesn't work. What's this thing supposed to return? Ugh. Send one thing real quick. Whatever closure returns should return from optimizer's step, ideally. So loss, losses. But that's what you did, isn't it? Got 0. Oh, but you can't do this. Let's just send screenshots of code, because that's a smart thing to do. It's breaking in step, right? Yeah, step closure. It should be like this, right? Oh, is that not the bug? Handle closure. Loss equals handle closure. I don't understand how this thing friggin' works. I don't know why that doesn't, Did I do something stupid? No. No, this gets policy.parameters, right? For each cache Newton PSGD. Return step. When you hit step, it should pass something back. Wait, when you hit step, it should pass something how it's back. Wait, is it? I've never actually used PyTorch that way. Oh wait, hang on. He sent me a thing. Loss equals model. Wait, but then the closure doesn't do anything, right? So why does it need a function like that? What? But wait, Evan gave me this like loss and batch losses thing. So he has return loss. But wait, what's that mean? Step. Closure. Loss equals closure. So you can just pass the damn loss in, right? They just have enable grad on this freaking thing. Confused. Then why do you have this entire thing in a closure? And then I'm confused because actually this just returns loss, not batch losses. So that's probably the bug. Here's another way to do it. Let's say you linked me. This is just how PyTorch works via closure. But this one needs a closure, right? This one didn't work without it. So cron. This is for Newton. You can't just do this, right? I don't know if you're still watching stream. Loss dot backward, create graph equal true. Wait. The README is not updated. Create graph. So it doesn't need a closure? This is default stuff. So do I just return loss? That doesn't work either. PyTorch works via. This isn't a closure. Fuck. I don't know why it would even need one anyways, right? Why does it need to compute the loss in that? Is there like some decorator it has to throw on everything? You can do it multiple ways. Okay. Oh, hang on, I got confused. Let's see, heavy. So yeah, it's this implementation. So this is not even okay. I see what you mean when it's a heavy ball thing. Okay, cool. HVPS default way is via closure. But I don't understand the signature that this thing has because it has this thing. Where is this? Maybe I just go find the source. I'm just getting tired here. 850. Is it 869 or something? Long ass thing. Yeah, so it's closure is none. Requires a closure. Loss equal closure. Well, it's failing on this param groups thing. Is this not how you initialize this optimizer? You have to give this thing params, defaults. Just takes params, right? Well, it looks like the loss definitely has to be closure. Oh, it just returns the loss. Then what the hell does it need the closure for? What the fuck? Modify closure of closure. So all of this just to add one stupid keyword. Why do optimizers have this stupid ass API? Second order LBFG will use closure. Oh, because it runs the stupid thing multiple times, doesn't it? But this doesn't run that multiple times, right? This doesn't run the loss multiple times, I'm hoping. Because otherwise that's slow as hell, and there's no point in it. This doesn't run the loss multiple times, does it? How is it not that slow if it has to run the whole model for it pass again, doesn't it? Two back props. So it needs a closure then, for sure. So why does it not work? 860. You're gonna tell me this and then it's gonna be like 5 steps per second. So there's something wrong with, I think, the optimizer, because it's failing on this thing, which is just like getting params and grads from self param groups. So I don't know how that happens. Right? I'm now realizing this is a double. Split P and G in group. Self-param groups. Lucas had examples somewhere. Now I cannot find. Yeah, I didn't see Newton in here. Oh, the closure is supposed to do the backward pass here. It's not just supposed to compute the loss, it's supposed to do the backward pass. Hang on. Yeah, so this is then not correct, I think. Well, this is just deleted now. There's no backward. Zero grad, and then... And where does he do this? Does it... Optimizer.step. And then zero grad. So I think this just has to have backward in it. That's probably what it is. Does this thing not works with frickin' So now I don't get Cudian N. I see, so it's different. Namespace does not support item assignment. He made this. The hell? Oh, the fuck? Yeah, he messed with this. I'm curious as to how he even did this. Shouldn't have had to touch my losses. How the fuck is this even broken? I'm like confused. Oh wait, hang on. Compute losses. Batch losses. Hmm? Oh, this might just be how frickin' Python works if you call this losses. Do I have to call this batch losses? What the fuck is this? Like, I gotta see how I had this originally. This is just like a random. Oh. I don't know how you break this badly. Oh yeah, you tried to get clever and you broke. Yeah, that's one. Lucas codes in a very particular way. Yeah, it's clearly functional inspired. Though to be fair, the closure API is from PyTorch. I have literally no time or patience for people who are like either very dogmatically functional or very dogmatically object oriented. They're both just a fucking waste of time. Though from Lucas's code, it wasn't that bad. This isn't Lucas's code. This is just a PR that didn't understand that you can't fucking do this because this is not a dictionary. It's fine. We'll do this for now. Closures used twice for two different gradients. Okay, so this runs now. If you would please tell me why this runs 30,000 steps per second, that would be great. Yeah, that's way too slow. As if I'm doing anything dumb, but I don't think so. What should it be at? At least 10 times this fast. More like 400, 500,000. So like, what do I do with this? It shouldn't be that much slower, right? Oh, it's the stupid QDNN probably on the LSTM. Because this didn't work without QDNN, like, right? It's probably the LSTM being stupid slow. I mean, not working with LSTMs is like kind of shit. I mean, I can run it without the LSTM, but then it's not going to do anything anyways. I can do that just to check. It works in jacks? Yeah, but then you're writing jacks, and then you get put on Suis. No, you get put on demonetized watch. Yeah, there you go. Fucking YouTube. Fucking YouTube, I swear. And Twitch. I actually don't know if you can get, you can even do that on X. I think you still get deboosted to hell. Are you on Twitch? Yeah, I'm on here, Twitch, and YouTube. Is it LRA? This is the Newton whatever you linked me. The fuck is this? Oh, maybe I just genuinely didn't test it with that, huh? I don't know what the fuck is wrong with this. Why is it still doing this? What in the... Ah, yeah, it's the stupid thing. $575K. I was at $575K per am still. I'm so confused. Bang. Well, there's no LSTM, so I guess it does have this many params. Oh, it's going to be that big-ass projection now. Okay, but this is smaller than before, and it's still... So with no LSTM, this thing is still, like, at least 2x too slow. Probably more. and it just doesn't work with an LSTM. Who the hell came up with the idea of a closure anyways? It's like god-awful programming. Freaking hurts my soul to have this even in the messy dev branch. So, presumably this means I can't use this, right? If it just doesn't work with LSTMs. Just to check, this is cron Newton, yeah. Newton P SGD. So it actually did get faster, it looks like. It is getting faster. But like it doesn't work with LSTMs. Because you have to disable QDNN. Yeah, so it got back to like reasonable speed, but I mean you have to disable QDNN. I mean, is there anything else I should try? Because I like. Masking still bugged, or did you fix that? I don't know, Spencer. We'll give you a finite difference. Yeah, let's try that before I go and like revert this stuff. And I guess it'll be up to me to figure out a way to make this not terribly awful. Like, what the hell is this? It's one-sided. Whatever you think I should try on this. Well, I'm gonna go back to the LSTM version at least. Build it into heavy ball. Closure. What? Can you add Mars? Well, this doesn't even run, like this runs at 30k steps per second, right? Maybe it gets faster eventually. Yeah, I know there's what, on Newton, or do you want me to run with like or do you want me to run just cron? What do you want me to run? Okay. Want me to just run this on MOBA since that'll be quick? Let's make sure this runs, and then I'll add Neptune. Once it recompiles the kernels and all that. Big delay in chat. I can read it from the Discord just as well. Yeah, X has a big delay. I mean, if you want, you can jump in the Puffer Discord voice as well. That also works. Twitch is faster. I mean, you can just jump in the Puffer voice unless you don't want to be in voice on stream. It's a lot easier. You pay for this freaking server for a reason. It's got like the max quality audio and everything.
Hello.
Hey, how's it going? It's probably a hell of a lot easier, right?
It's so much easier.
This is kind of dumb.
Yeah.
Yeah, okay. So, I'll run this on Puffer MOBA real quick. Because Neural MMO3 usually takes a little bit.
Yeah, so I think Mars. Okay, so
What does it
Mars
do?
is a variance. Yeah, it's a variance reduction technique. All that it does is it says I'm going to take my current gradients and subtract my previous gradient information from it. And so in some ways, it acts as like a Hessian vector product, right? It'll do a finite difference.
Wait, I'm going to take my current gradients, and then I'm going to subtract my previous
gradient from it.
Gradient, not gradient variance.
No, you're just your previous buffer.
So this is right? Gradient scale invariance, right?
Yes.
Not gradient variance invariance.
No.
Okay.
Yeah, no.
Is there anything that does that?
Gradient variance invariance. What does that mean?
So if you're training on a language model, you kind of have like the same problem everywhere. So you can tune your params and it'll just work. In RL, different environments are going to give you different gradients, and some of them are going to have very high variance and some of them aren't.
Yeah.
And that screws up your hypers.
I see. So.
And you just have to adjust the learning rate is all it is. You just have to adjust the learning rate. But it would be really cool if that could have been done, like if that could be done automatically.
So with PSGD, okay, so I will not only talk about the things I do, but what other people do as well. So there's a work called Deadapt by DeFazio. I'll link you right now. And yeah, so there's this work, Deadaption, and I've built this into a variant of PSGD.
Where'd you link it?
Yeah. Is it okay if I drop it in the Puffer chat?
Yeah, whatever.
So there is a newer version called Prodigy. But I have actually found Deadaption. Okay, Prodigy is a little bit more aggressive than Deadaption on its learning rate. I prefer Deadaption to Prodigy, but you could consider both.
So I can try this. I will say that I tried a couple of the learning, like the schedule free or whatever, in Heavy Ball, and they just didn't work.
Yeah, okay. So schedule free is something different. Schedule free will absolutely not work for reinforcement learning. And it also will not work for a lot of smaller tasks. What schedule free is doing is so it'll work great for language models, right? Because it has this basically thing where your problem is basically the same over your entire setting. And
Yeah.
that's not true for RL at all.
Yeah, we know.
Right?
Language model people, they like to solve easy problems.
Yes, no, exactly, right. And so with schedule free, what it's doing is it's literally doing an interpolation on the weights through time as well. Right. And so you're finding some like interpolation of a bunch of solutions, right? And this absolutely will not work in many settings, right? Um, but de-adaption, all it does is it just does some upper or lower bound on some stuff to basically find a good initialization for your learning rate.
Is this like a thing that you could, because it says for Atom and stuff, could you throw it on Muon or something?
Yeah, you could.
On PSGD or something?
I can, if you really want,
Well,
I can wrap something with Muon
I
if you
will
want,
just,
or
instead of what I really want, look at it this way. I have a lot of experiments that I can run very, very quickly on relatively interesting problems. So if that is useful for testing stuff, because, like, I mean, this is a way harder Optim benchmark than something like an LLM, right?
no, I agree.
Yeah. So I can run this here. It's running on Neural MMO now. We'll see if it does anything. And by the way, here's your Mars result just immediately.
Yeah,
So this is very slightly better, potentially,
yeah.
or
So
comparable. Probably in the noise, to be honest. But then the reason I didn't use this is because I saw this, and it has a little bit of a, doesn't have a little bit of a perf penalty, or am I making that up?
it doesn't have a
Oh,
what? Sorry.
it doesn't really have a perf penalty. It's kind of the same
No, it
speed.
doesn't.
Okay.
It's a memory penalty.
Oh yeah, we
Um,
don't care about that. We have infinite memory.
yeah, exactly. Um,
Yeah, we have infinite memory until we have to start offloading stuff, because we do have
yeah.
we keep batch size. We will keep like batch size 500,000 in memory.
Okay, so here's something kind of interesting with PSGD. You can more or less set your batch size to 1, and it will just do fine. Um,
You can set your
and that
batch
is
size to
not
1 and it will do fine.
yes.
That cannot possibly work because LSTM.
Okay, on LSTM, I don't know,
Maybe
but
one trajectory segment.
yeah, maybe one trajectory set. Yeah, yeah.
Okay.
For LSTM, but for like images, for example,
Mm-hmm.
you can set it to 1 and it'll do fine. The other thing you can do here is you can okay, so I don't know what hyperparameters you play around with, but just to kind of explain, like PSG is something very different. It's an optimization framework in itself. So there is the neural network side of things, which you're minimizing, right, with your preconditioned gradient descent. But then there's also your what is it called? There's also your preconditioner fitting. So you're running a convex optimization problem to learn your preconditioner, and then you're also using that preconditioner to precondition your gradients to minimize the loss of your neural network. So if your preconditioner is too high or too low, the learning rate of that is too high or too low, it can also mess with it.
Yeah, so I can run a sweep on that. That's no big deal.
Yeah, yeah, which is why I thought. I mean, I remember when we met at what was it, Currents?
Yeah, I can probably run. I mean, Neural MMO 3 will train like, I don't know, 1.5 billion steps an hour at least. So I can just run like a good chunk of experiments even on that. Are the defaults generally not, like the preconditioned defaults not good, or?
No, they're good. And Evan has seen them be pretty good. And
This
so
is
have I.
Mars, by the way.
Nice.
Now, but the thing is like this, You see what happened with the last run is it did way better, and then it just like didn't. It got stuck completely.
Yeah, so you can, I mean, what's the LR precon right now? Probably 0.1.
Whatever default is. Let's just see.
Just quickly reduce it by an order of magnitude.
With
So,
Mars?
yeah, without. The other thing is,
Yeah, what's the
you
param?
can uh,
Or is it heavy ball specific?
yeah, I don't. That's the thing. I either use Zealand's implementation, which is also heavily my implementation. We kind of wrote all that together.
Oh,
Or
I'll
I'll just,
test it, sure. I tried
yeah,
Evan's implementation of PSGD and then I tried this one, and Evans got like 350 score on breakout, and this one solved it with the defaults.
yeah. So you can look at Zealand's code. It has a lot more optimizers than Evan's code. But it's also written in a way that might make you want to pull your hair out.
Oh,
Um,
lovely.
every
Which of
single
these
thing
params should
requires
I change,
closure.
by the way?
Yeah, let me see. It should be like, okay, LR, weight decay, preconditioner, update probability. No, not that. Okay, precon to LR, it's the last one. So there's also this precon to
Oh,
net scale,
so just
which are
reduce this
in the
to
X.
0. Oh, it's 0.1.
No, yeah. Yeah. 0. 0.01.
And you will
There's
get
also the init
immediate
scale,
results.
and that I think it was just added into. I don't know if he's pushed it, but he's seeing like much better results with the way that Zealand automatically sets it.
Well,
In
we
his
can
code.
definitely try that. So here's the cool thing
Yeah.
with Puffer, right? As a benchmark for this type of stuff.
Mhm.
And I'm sure you've seen this, but like we have all these N's and they're fast. And we actually have more in dev, some of which are pretty cool as well. So like if it just works on all these, it's probably pretty good. And
Yeah,
like
no,
most of these will train in a minute.
yeah,
Some of these, maybe some it's like 5 minutes. But the only ones that are like really hard and take quite a bit, it's like Neural MMO3 is pretty hard. Other than that, you can like kind of just go fast.
what are your thoughts on all these? I mean, new. Again, I know we're getting pissed about me saying this. Not pissed, but what are your thoughts on like GRPO and all that stuff? Do you think
They're
eventually, I
language
mean,
model
Puffer's,
specific.
yeah, for sure, right? But do you think that you would ever consider putting like a language model into Puffer and just play around with the different RL algorithms, whether they're specific or not to LLMs?
I mean, I don't see the point. It's like an easy problem. If they can't figure that out, I don't know what to say because it's like you have a tenth of the number of problems. The only thing that's hard, like really the only thing that's hard about language models is the getting like very performant distributed training. Like there's this whole extra stack that you have to deal with to make stuff fast. You get like multi-million step per second training. None of the stuff I do in Puffer matters if your model trains like 0.5 steps per second, right?
Yeah, that's fair.
Like GRPO is a one-step problem. Like it's being used for one-step problems, and now like there are these papers coming out for a multi-turn learning, so they're like a few steps in the future, which is actually good. Like that's how you would use RL on a language model, and I think that there's actually a good chance that that does really great stuff because RL is really powerful. But that's not really my concern because people are going to do that stuff with or without me, right? My concern is mainly like, how do we make sure that all the research that really matters for RL and RL methods to be good, that gets done? Because nobody else is doing that. This is how I view stuff, right?
Like you're saying multi-step on LLMs. Is that what you're saying?
There are a couple people doing that now, but like, I mean, it's taken so freaking long. Like, I don't even
No,
know
I
how it takes
agree.
you this long, right? It's been like 3 years or whatever, 2 years maybe. I mean, still, you have how many $1 billion in this, and like everybody goes nuts over one step RLHF followed by one step RL. Like, come on.
No, I agree.
So I'm not
No,
pissed
I
about
agree.
it at all. It's like, yeah, good, you should be doing this stuff. If anything, it's kind of embarrassing that it took that long. But I get it. The reason it takes that long is because your experiments are so bloody massive that you can't run very many of them. So what do? Instead of running like, one experiment, which is all I'd be able to do with the hardware I have, right? I've made Puffer, so now I've run 25,000 RL experiments since the start of the year,
Yeah. No,
right? So my concern is really more, how do we develop RL as a core tech, right? How do we make sure core RL makes progress? And I cover everything but language models for the time being.
yeah, yeah,
And there's so many problems in industry where language models just don't make any sense. So, I mean, they're too big. The priors that they give you are not useful because the problems are really unintuitive. You just need to train from scratch, and it needs to be good and it needs to be fast. So that's what I'm looking for.
yeah.
Okay, by
I
the way, that
agree.
matches the I don't see any noticeable difference in the curve yet. We'll see. But it kind of looks flat.
Interesting. I guess turn off Mars maybe, and then reduce it even more.
Yeah, that's flat.
Drop by order of magnitude.
Yeah,
So if
that's flat.
that, if that, like, if that doesn't, oh, wait, was that cron or was that cache? No, that must have been cron, right?
Cron, I didn't see any difference with cache.
But it's not Newton, right?
What I ran this with before was Mars True pre-con to 0.01.
Okay. You comped it out the top line, I guess.
Yes,
Yeah.
commented. Color scheme included with our Docker container. Huh? But yeah, Neural MMO3 is like a really hard and interesting end. Like you can play it right here, right? If you just hit control, you can take over and you can play it. So I'm
Yeah.
taking over now for this guy. And like you will see that it takes quite a while to like figure out how to even do anything in this. And like there's so much stuff that just like the delay is very long in what you have to do. So I have to go kill this enemy. I have to equip this tool. I have to go find something that I can actually harvest, like this sword. I can go pick up this sword. And then I have to like unequip this, equip this, and now I can go find something like very slightly higher level and maybe go kill that. And there's like a market, you can trade with other agents. There's like armor and equipment and weapons and consumables. And then if I let this agent just take back over, the map looks like this. It's big. There's a lot of stuff that can go on in here. Really nice benchmark for this stuff. Way
And
harder than
Adam,
anything else.
and Adam, what does the Adam curve look like?
Hang on. Let me get rid of this bot. There we go. This is Muon. So this is Muon, and actually this is not the best metric. The best metric is this mincom prof. This is like how many levels you get. So this looks really good, right? But now if I just do this. So this is the learning curve. Very smooth. And then if I go find the Wanby curve for you, there's the Wanby curve. Man, I thought I had it. Oh, here it is. Nope. Yeah, this is the Wanby curve. So it gets up to about, was that 2.5? This is about 1,500 years worth of games played. 73 billion
What?
steps. Yeah. There's about 1,500 years worth of games played.
Wait, is that like in game?
Yeah. Yeah, if you were to play the game in real time, this is 1,500 years worth of game. And then this one here, this is about 1,000 years worth of game, little less.
That's kind of absurd, isn't it?
I started this run on one GPU less than 24 hours ago.
Kind of crazy.
Yeah. So it's very fast, and you can kind of learn some pretty complex stuff because it's like, oh, what can you learn with a small model on one GPU? It's like, well, when your x-axis is in tens of billions, I mean, you can go look at the large-scale industry papers, and very, very few of them have an x-axis in the tens of billions, right?
Yeah.
So you can kind of do a lot. Let's see where this graph is. All right, so your blue one here, this is your blue one.
Okay. Let's see how it does.
So it starts off way lower, still better than Muon, but then we'll see how it converges. What's this thing that Evan said, like, oh, learning fast is bad?
Yeah, so
That seems like a screw up.
no. So there's a concept called neuroplasticity.
Yeah, I'm familiar, but it's kind of stupid that that's a thing.
I'll send you. Basically, I can explain what the experiments they did. They took a CNN and they, for the first like Sci-Fi 10, right? They train it for the first like 5 epochs with blur, first 10 epochs with blur, first 30 epochs, first 50 epochs with blur, and then after.
Yeah, no, I'm familiar with neuroplasticity, right? I'm familiar with that line of work.
Okay.
Oh, this doesn't seem like it helps. Like, this goes up and then goes back down immediately.
Yeah, I mean, let's see what happens.
Muon was pretty good here. I'm surprised. I mean, the other thing is manually tuning hyperparameters is kind of dumb. Like, I probably could just sweep this. But what do I sweep? Do I just sweep the preconditioned learning rate and the learning rate, or do I sweep other stuff?
Let's see what else is.
And we have a lot of fun stuff that we can play with.
Yeah, exactly.
Unfortunately, these sweeps do take a little time because, big run. But
yeah,
all the other sweeps don't take much at all.
Okay. Can you also do like binary, like true false? Yeah, right.
In sweep, I haven't, but we probably should. Yeah, we could. What, you just want Mars? I just run 2 sweeps. Mind you, we don't have all our nice hardware yet. 5090 test machine should be in sometime this week. We order more of them.
Sorry, I think my internet cut out there for a second.
Mm-hmm.
Wait, can you hear me?
Mm-hmm. You there?
Yeah. Sorry, I think my internet cut out for a second.
Yeah, you're good.
I probably would also. So there's this other setting which says, okay, so are you familiar with caution?
Not as it relates to optimizers.
Okay, yes. Okay. So caution is set to false. You can try toggling caution true for both muon and PSGD. It basically says if your gradient and your update, right, have sign changes, ignore them. Set that dimension to 0. Caution is interesting to use. There's also this, if you do enable Mars, there's a Mars gamma, there's the momentum. There's also this option that says momentum into precon gradient. Okay, you can set that to true and false.
Oh my gosh, you guys have added so many friggin' hyperparameters.
Yes,
Holy.
sir. So
yeah.
well,
So
that's
is
the
there a
point.
comprehensive? Is there like a comprehensive thing on this versus muon anywhere?
So okay, so if you use heavy ball, I think every single optimizer has all these hyperparameters.
Yeah.
So this is Lucas's idea is it should all compile and it should all be so functional that they can all just you could use any mix of optimizers together. You're asking for a comprehensive understanding of muon versus
I'm asking if there are experimental results, right? If there are experimental
results.
So like the thing that I went for muon, right, is people were trying pretty hard for a bit to get the GPT speed run, to get that working, right? So I saw that muon was good on there, and I said, oh, okay, maybe that's useful. And then I went and I tried muon on a bunch of M's, and it was, it was doing, and after I ran a sweep for hyperparams, the muon was doing better than the other ones, right? Than Atom, it was doing, solving faster. And then I tried this thing, I tried PSGD, cron, and it matched muon just with the defaults on breakout out of the box. And it did better on MOBA versus not fully tuned muon params, but like good. Yeah. Default did better there. And the only thing it hasn't done well so far is neural MMO. It gets stuck. So I don't know if there's something weird with the optimizer that causes that or what, but muon doesn't get stuck. Muon has a very, very smooth learning curve.
Yeah. So we have like our own internal results, and then Stanford also has some results of PSGD versus muon. But this would definitely, like, the stuff you're doing is, I mean, I've been trying to get PSGD into Puffer for some time now, and I just haven't had,
Yeah.
the bandwidth.
Well, here it is. We'll see if it takes off at some point, but it's just intersected with muon.
Yeah, so we're really reducing the LR of the precon a lot. We can also try reducing the momentum, for example. That might help. Another thing that I have to check if it's in heavy ball or not, that Zealand does differently than Evan. Zealand trusts the gradients. Evan trusts the momentum. Right. So that was if there was a if there was a contribution Evan has made, it was that he said, hey, let's try to trust the momentum term, which I also had done, but he kind of did it. He showed that it helps on LLMs a lot, but maybe for RL it hurts. So instead of passing the momentum term into the preconditioner and preconditioning that, you can just directly pass the gradients, which is what Zealand's codebase does.
I'll have to look at that. The thing is, this isn't even an optimized muon, right? This is I optimized muon on breakout, and then I just use some of those params like the atom betas and stuff. I use them here. I don't even think this is like an optimized muon for this. It's a little weird that like qualitatively the behavior is it gets stuck that early.
Yeah, I don't know why that would happen.
I don't
Um,
understand. Like, I don't actually know the math behind this versus muon. Like something's very different here.
yeah, so I've reduced the learning rate of the preconditioner by a lot. So it's gonna take a while to I basically okay. So now this is reducing it by like 2 orders of magnitude. You can also increase it by an order of magnitude. So but I might throw carbs at it or protein at it.
Okay, well I'll just run a sweep then. I'll sweep some stuff and I'll see if this feels like this can do anything. Because I did start a muon sweep on. It's a little annoying to get the thing to actually like consistently run experiments that are like this long, but so let's see, man. Yeah, so like there are like some results here. This one looks pretty good. 0.02. Like, this is above where PSGD got stuck, I think, here. So there's definitely sensitivity,
Yeah, for sure.
but it's way less than before. Like the atom sensitivity is crazy by comparison. All right, well, I'll let this run. I gotta go get dinner. Thanks for the help on this.
Okay.
And yeah, I think just
Yeah,
generally,
of
if you
course.
want to do Optim stuff, right, we can just kind of use Puffer as a benchmark, and then you also use, the algos for Puffer. Because this has been like a major thing. I mean, the cosine annealing was also pretty major, but I think overall this has been the largest thing I think this is like going to be the biggest RL advancement in this year so far. I mean, I know Evan's been running this stuff, but he hasn't been running it on all these different M's, it seems, because like qualitatively, I can tell you this is a step change in capabilities in terms of just how janky everything is. I don't know if he was trying to run like all the arcade games with the same sets of parameters and stuff, but like if you try to run all the different puffer M's with the same set of atom params, they just don't work. Like they're very different tasks. It's not like you just have a bunch of arcade games, right?
Yeah, I mean,
But now stuff works.
I've been trying to get PSGD into. I mean, if you go and look, PSG 2015 puts this out,
Hmm.
right? Like Mulan was made 2 months ago, 3 months ago, after I kind of was pushing for whitening based optimizers for like a year and a half.
Is there I
In
mean, I
Alpha.
gotta look at the math difference between the Muon and PSGD to see what they do differently.
PSGD is a much wider framework, right? So PSGD can do Muon, it can do shampoo, it can do soap, it can do KFAC, it can do Atom, it can do all these different things, a bunch of different preconditioner shapes, and like way more types of things than any other type of optimizer I think in existence.
Well, in that case, if these things are parameterizations of PSGD, the question is like, do you have one that's better than, do you like, you're going to look for a small set of hyperparams that are roughly stable across a wide range of problems, ideally, or are relatively easy to tune.
Yeah, and I think also the preconditioner style, right? The shape of the preconditioner, right? This is a Kronecker factorized version of the preconditioner, but we also have low rank approximations. We also have sketched approximations, right? We have all these different shapes. we can do like, and the point is, let's find what's the best. And I think Puffer is really good for that because clearly you can run like 1,500, 15,000 years of gameplay in 24 hours, right?
Yeah, that's pretty fun. That's out on one GPU. We technically have multi-GPU support as well. We've got one client who's tried it up to like 64 GPUs, and it does work. We don't have that hardware at the moment. We're gonna get some pretty soon, but in the meantime, like all the simpler RAMs, they just run so fast. You can do these in just a minute or whatever.
How
Yeah.
expensive is it to build a new app?
What do you mean, how expensive is it?
Like, let's say a client comes to you and says, "Hey, I want to get an agent that works really, really well on my setup. You build me a simulator that would then transfer to the real world or something." I don't know.
Oh, I mean, it depends on what people want. And it also depends on like if the Sims are going to be closed source or not as well. Starting though, like Puffer service packages, if you just want like priority service on features within Puffer, not new Sims, and you just generally want assistance with that, that's 10K. And then when you start getting dedicated work on your stuff, like if you want dedicated work on a new sim or something, then I get at least one contractor involved. So that starts at 20K a month, and it goes up depending on the amount of work that's needed, because that's priced for like quarter time work. So if you want people working more hours on it, then it goes up from there.
20 grand a month.
Well, that's for me. That covers me plus a contractor, and that's it's a slice of my time. And then a contractor's quarter time.
Nice. And how do you find contractors to hire?
I mean, one I had from a previous collaboration. Another one that we just finished was a Twitter cold DM, and then another one that I just started is from mutual acquaintance or mutual colleague. And then we've had a few others that haven't gone through all the way, that have been from either cold contact. I mean, we had a few leads from GDC that almost worked, but I think Puffer has to get a little bit bigger to be landing the larger companies because it's new. But yeah, stuff. It's generally, this is just their service as a service, and we're trying to make RL really, really fast, and we've got a bunch of good tools, and they're all free and they're open source, so you can just use them. And we actually encourage people to go ahead and use them first to make sure that they see what we have. But if you use them and you're getting some good results, well, why wouldn't you want to have us involved and on your side to make all your stuff work way, way better, right?
Yeah, makes sense.
I mean, I have clients, right, where it's like, I know that this thing that I was just developing on the algo side is going to be perfect for your end, and I'm just like, throw it on that immediately, right? Otherwise, you'd have to wait, like, you'd either have to be watching the dev branch like a hawk, basically doing what I do anyways, or you'd have to wait until everything comes out, and it's still not out of the box. It's all right, it's hard, right?
Yeah.
But yeah, I mean, the goal longer term, right, is that as we make RL more stable and more consistent, we just spread throughout a whole bunch of different industries that have sims that need optimizing. And, we start taking on harder and harder and more valuable problems with it. And then the prices will obviously go up from there, right? Like, we're not going to make somebody $100 million for 10, 20K a month.
Yeah, so you actually did some work with OpenAI, right?
I interned there in undergrad. I took Neural MMO there, and then I built the 1.0 version out from there. It was like 2018, I think. It was cool. That was when they were doing Dota. It was really cool to see that.
Yes, I mean, what happened with those, like, with that lead or those contacts, right? Like, it would make a lot of sense, right? But or is OpenAI not interested in?
They're not doing that anymore, unfortunately. They like the Dota stuff. If they kept doing it, RL wouldn't be in such a bad spot right now, where I have to be doing all this stuff. Because the Dota team, I think more than anybody, they were crushing it in reinforcement learning. They had the hardest problem.
But they like destroyed like the top teams, right?
Yeah, but so they could have then tried to go and do it with 1% of the compute. They discussed doing that, but they didn't. They kind of all moved on to language model stuff, right? They could have done so much work around that problem because they solved Dota using very simple methods, right? There was so much room for ablations, like what really matters at scale on these hard problems. There was so much room for that. And frankly, a lot of the stuff in the Dota paper, if you like really go through the appendix, is stuff that people would keep rediscovering and not really learning the lessons from for the next, I mean, even through till today. I don't know how many times I have to tell people, like, who are trying to throw a transformer on a super basic problem, that a one-layer LSTM solves Dota.
Yeah.
I mean, people think it's not possible to solve X problem without like fancier method, fancier architecture. It's like, no, one-layer LSTM solves Dota. They say, oh, but they used a ton of compute. Yeah, they used a ton of compute for back then. It's not that much compute at all by today's standards, and it's a way harder problem than most people are dealing with.
Okay, so then why don't you want to try to attack language?
Because everyone's doing language already. It'll get done with or without me. Nobody's doing this, right? Nobody's doing
No,
core
I
RL.
know, but clearly, like the way that they're doing the language is just by scaling up. Do you think? I guess the right question is: do you think that we could solve language in a way that is, cheaper, faster, you know, smaller models if you're just using, something better than next token prediction?
Nextpo token prediction is pretty good. The problem is, so that's like a good base is the thing, but then you need to be able to learn through interaction, which is what RL gives you. But like the thing is, labs are going to do that anyways, and they're going to throw way more money at it and way more resources at it than I can possibly muster, right? The thing is, like, RL's been thrown to the wayside, and like general purpose RL's been thrown to the wayside, and I can make so many core contributions and advancements by doing stuff the way I have in Puffer, right? Like I'm finding stuff that people haven't found in the last decade because I can just run experiments 1,000 times faster than them, right? Like I keep finding the vast majority of published RL methods are straight up wrong because they didn't bother tuning hyperparameters because their M's were too slow to do it. I can actually do that, right? I can run exhaustive experiments. I can run ablations, and I can do them very quickly, which is why you see a lot of the techniques in Puffer, right? They come from the just ridiculously rapid speed of iteration.
Yeah, that's true.
I don't know. I just don't really have any interest in like jumping on the general LLM bandwagon because like, what am I going to do? I'm going to try to help them like leapfrog the next other LLM company out there by a couple months, right? Like, not really all that interesting. But if I can just put all of RL as a field forward, that's going to help everything.
Yeah, that's good. I guess, I know you said you have to quit dinner, but
Yeah.
I'll see one last thing. Your clients, who are they mostly? Like, are they robotics companies? Like,
We only have a couple at a time typically, because I'm mostly focused still on a lot of dev around Puffer, so I try to save a fair bit of my time for that. But so far it's been random. Like, we did stuff in animation gen. We do stuff with, there's another research lab, stuff in finance now. Like, and I think that going forward, there's going to just be a ton of random stuff in manufacturing as well. Just random industrial processes that are unintuitive and need to be optimized. Like everybody's got an optimization problem, right? And a ton of them actually can build sims for them, good sims. So RL's, I think, going to really improve just a ton of these random processes where language models, like the intuition you get from language doesn't help you solve arbitrary optimization problems, right? But RL does.
yeah. I mean, could you do like you said finance? Would you like do like high frequency trading or like?
Yeah, and like I can't. The thing is, a lot of the clients they have NDAs on like you can't say exactly what they're doing, but I mean I don't have.
But I
The
could
thing is, I don't
imagine.
have interest in any specific area, right? I don't really have a vested interest in any specific area. It's more so like RL in general, what can we solve with this? Let's throw it on a ton of stuff. Let's just bring all of Puffer's tools, right? Just try to see if this can actually work on all these different problems. And then anything we learn comes back to Puffer, right? Anything that we learn in the process about core methods comes back to Puffer. So the more different types of problems that we get to see, and the more different types of problems we get to throw Puffer at, the better Puffer gets.
So it's basically like a work-study program in college.
Well, it's more so that we do work for people, but we end up keeping a lot of the code open source because it's actually to their benefit to keep it open source. Because as soon as it's an open source in Puffer, right, we get to test all of our new stuff against it, and our users get to test all their stuff against it. So like you get so much free progress on your thing by keeping it open source in Puffer. It's really to your benefit. Like, who cares if you have a simulator, right? If your simulator is open source, like, you still have a business around it, right? And you're still the first person on that business around it. There's so much other than just the sim or just that code. So, and if you're able to move faster because the stuff is open source and Puffer, then why wouldn't you? You don't want to deal with RL. It's really freaking hard, right? Let us deal with it.
Yeah. Yeah, it's true.
The other nice thing about it, right, is because Puffer's all open source, it's really easy to work with us because companies are worried about like, third-party SaaS, like outsourcing capabilities behind like a closed source wall or behind like a service model paywall. You don't have any of that, right? You just use the code. The code's really simple. You can in-house some of the RL capabilities if you're interested in doing that, and you get all the updates for free. You're just paying for assistance on stuff. So.
Yeah, that makes sense. It's actually an interesting model. Plus, you get like eyes on Puffer too.
Yeah.
It's open.
Well, it's not the best model for pure profit, but that's not my motivation, right? I want to make money, but I also really want to make RL work as a scientific field. And this is why I haven't even gone for VC money of any sort, right? Like the stuff I just did, like just even the results of throwing Muon plus the other tweaks that I did at Puffer, no VC would let me release that because like the quality of those results, right? Like literally RL is a different field today from 3 days ago because of Muon plus a couple of these other optimizer tweaks, cosine annealing, a few other things, some bug fixes. I mean, you can't see it yet. You can't see it yet because you didn't see the experiments. But like the difference between you having to run 200 experiments to get a specific set of hyperparameters per env and the defaults roughly working out of the box now with all these new changes that's a qualitatively new field, essentially. Right?
So I guess in my paper, it's funny. In my it was 2021, 2022.
Mm-hmm.
I did PSGD on RL and I saw results and I did cosine annealing, but I was just using like a really shitty reinforcement learning like package.
Mm-hmm.
And if I had, put it into Puffer in 2022,
Mm-hmm.
it would have been
Yeah.
a lot better.
Yeah. But that's the thing, like, the amount of effort it took in order to get to a state where we can do that? We now have 30,000 lines of C environments.
Yeah.
Right?
I think it was even before. I did this in 20. I want to say 19. I did a Flappy Bird RL thing
Mm-hmm.
with a very early version of PSGD. It was PSGD counterfactorized, and that worked quite well. And there was like, I could pull up that report actually.
Yeah, if you want to.
I'm not claiming to be the first one to to use Muon or use PSG or anything for RL, right? The point is the catalog, right? The catalog of different problems and the ability to like get these exhaustive results so quickly. Because
that's my
I
point,
can
right?
literally, so if I wanted to like prove algorithm A generally better than algorithm B, right? I can give you, it would take like maybe a week's worth of experiments, but I could give you a
Yeah.
200 parameter hyperparameter sweep for every one of these environments.
No,
Like
exactly.
a 200 experiment
right?
hyperparameter sweep for every one of these.
It's increasingly difficult to convince people of anything,
Hmm.
but this makes it possible
Mhm.
for at least for RL.
Yeah.
Well,
All right. I'm gonna go get dinner. Let me see. Do we
Yeah.
have folks watching? We have a few folks watching. So let me just say real quick for the folks on Twitch, if you're interested in checking out puffer.ai, go ahead and star the repo. It really helps us out. And if you want to get involved with dev, build some cool environments, push RL forward, discord.gg/puffer. It's right here. And follow me on X for more.